All right, back down here in the lab again. This time we're going to do a reaction. Essentially, we're going to do equation writing and a little bit of stoichiometry. So I have here a bottle of sodium carbonate. That's the white powder you see here. I realize in a chemistry lab, mysterious white powder is, sometimes an iffy proposition, but I assure you that's what it is. Over here, I have my bottle of hydrochloric acid solution, and that's the reaction we're going to carry out. I'm going to essentially mix sodium carbonate plus hydrochloric acid. We'll talk about the reaction, balance it, and do some stoichiometry on it. Have my balance over here and a beaker with a stir bar in it. And first thing I'm going to do is just simply put the beaker with the stir bar on the balance. And these electronic balances are kind of nice because you can zero them out so that there's no mass of the beaker and stir bar anymore. And so now I carefully take the mysterious white powder, the sodium carbonate, and I make sure it all gets into the beaker, and I have the mass, 2.53 grams of sodium carbonate. So that's going to be my starting point, and now I'm going to change out the setup a little bit. I'm going to get the stir motor over here, and we'll actually carry out the reaction. See you in a bit. Okay, we're back now. I've got a stir motor and hot plate in place of the balance. There's our sodium carbonate, and here I have just plain old deionized water. And what I'm going to do is pour a little bit in there. I don't really want a whole lot of water, but I'm going to try to get it to dissolve. Now, of course, this is the time where we would come along and stir it, but you don't think we actually really stir these things anymore. What I've got in there is that little stir bar and this stir motor. And the stir bar is a Teflon-coated magnet. The motor here is a magnet that is rotating, and it makes the little stir bar in the beaker spin rapidly, and it stirs our solution. And you can see the sodium carbonate is starting to dissolve. The solution is getting a little bit clearer. And so what I'm going to do is give it a few more moments to completely dissolve, and then we'll start the reaction. Okay. It took it a couple of minutes, but the sodium carbonate is now dissolved. You might hear the stir bar in there kind of knocking around. I moved the camera just to make it a little bit closer. Because now we've got our sodium carbonate solution. It's time to start adding the hydrochloric acid solution. And when they mix, you're probably going to see a few bubbles. Okay, it'll be kind of interesting when it happens. And so you put it in there. Notice how it fizzed and foamed. Put some more in. Put some more in. Oh, that's so cool. Now, what I'm doing is I'm not doing a limiting reagent question. So what I'm after here is basically to react all of my sodium carbonate. And I'll know that I've done it is when I add hydrochloric acid and I get no more fizzing. Okay, the fizzing is carbon dioxide that's being formed, and we'll talk about the full reaction in a few moments. And so as I keep adding my hydrochloric acid here, we keep seeing it fizz. That means there's still unreacted sodium carbonate in there. And so my limiting reagent, I'm deliberately setting this up, so my limiting reagent is going to be the sodium carbonate, and my excess reagent is going to be the hydrochloric acid. Okay? And so I keep adding the hydrochloric acid, keep still seeing it fizz, which means the sodium carbonate is still in there and still reacting. Put a bunch in there, and a bit more. There. You notice I'm adding it now, and we're not seeing any more fizzing. Now, I'm seeing a few bubbles from when the liquid goes into the beaker, but that's not the fizzing reaction of forming of carbon dioxide. So I've used up all of my sodium carbonate now. The other product in there, of course, is going to be sodium chloride and water, and the carbon dioxide you saw coming out of there as fizz. So what I want to do now is do the stoichiometry problem and the percent yield, I want to reach in and grab the sodium chloride. And so that's going to be a little bit tough. So what I'm going to do is actually get rid of the water. And that's where the hot plate comes in. What I'm going to do is I'm going to turn the hot plate on, and basically I'm going to evaporate all of that water away, leaving behind the sodium chloride. Okay? And so, getting that all prepared, what I'm going to do is turn the heat on, and we'll turn it up and get it evaporating. Now that is going to take a little while, and I did seriously consider leaving the camera running for the hour or so it's going to take to evaporate that water, but let's face it, that's probably not going to make the world's most exciting video. And so what I'm going to do is you stop it here, and we'll come back toward the end. All right? So be with you in a few moments. Down here on my friend the light board now, so we're going to do a little bit with that the stoichiometry problem that we were working with. So remember, we had sodium carbonate, and writing that out. There's its formula. And of course, we know it's aqueous. We even saw it dissolve. So we put the little AQ here. I reacted it with hydrochloric acid, and that too was in solution. So we had an aqueous solution. Now, the products that we're going to make out of this, it's going to be a double displacement type reaction. We're going to get sodium chloride, and that too is going to be aqueous. All right. The other two products that are going to come out of this are actually water, that will be liquid, and the carbon dioxide. That was the gas, that was the fizz that was going on. Now, so there's the reaction. Now we do have to balance the thing. You notice we have one chloride on the left and one on the right, but one sodium on the right, but two sodiums on the left. So I do need to get that to balance. That means the chlorides need to be balanced as well. And now I pray to the chemistry gods that everything else balances out correctly. 3 oxygens, 1 oxygen here, 2 more there. Ooh, that's good. 2 hydrogens, woohoo, and the carbons. All right, we've got this thing balanced. Now remember, what we had is 2.53 grams of this one, of the sodium carbonate. So let me weigh it out. And what we're after is, how many grams of the sodium chloride can I expect? What is my theoretical yield? Okay, so now let's go ahead and get theoretical yield. We have the 2.53 grams of sodium carbonate. And of course, I wrote down over here on the side, 106 grams of sodium carbonate is 1 mole of sodium carbonate. Okay. First step with the stoichiometry. 1 mole of sodium carbonate is, there it is, 2 moles of sodium chloride. Okay. And then finally, 1 mole of sodium chloride weighs, and there it is, 58.45 grams. And so we punch all that out on the calculator, and I got 2.79 grams of sodium chloride expected. Okay, that is my theoretical yield. So, still up there, evaporating. Okay, like I said, that's going to take a while. So I came down here and do a few calculations. When it's done up there, well, I'll show you the result. We'll do the weighing. We'll do the weighing of the thing and find out how much we actually got. Okay, so we'll be back with you in a few minutes. All right, we're back up here in the lab, and I moved the solution from the sodium carbonate reaction here to this evaporating dish, mainly because it'll make the evaporation process a little bit faster. Also allows me to do it in the fume hood. It And I'm on my grungy old, this thing has been through the war, hot plate here, the stories it could tell. But what I wanted to show you a little bit here is, and on the video it may or may not be easy enough to see it, but with the flashlight I think it shows that nicely. You can see a lot of steam coming off of the top of the solution there, especially if I move the light in just the right position, or move it around a little bit. And so yes, indeed, we are driving a lot of that excess water off, and with a little more time the solution level will continue to drop, and the sodium chloride that we created in that solution will start to appear. So we'll be back down in a few minutes later. Well, here we are back in the lab again, and it's actually the next morning, because unlike a virtual beaker or item in a virtual lab, a real one takes actually quite a while to cool back down before I could weigh it. So there it is. You can see the weight. The evaporating dish and the material inside it is 73.89 grams. We're going to deal with that in a moment. I wanted to show you, so I'm going to go ahead and grab it here, hold it up a little bit. You can see there's a lot of this white crystalline material, and it may even look a little bit better if you shine a little bit of light on it. I'm not sure if it'll show up on the video well, but you can kind of see some of the sparkles of the crystals that are in there. Okay, it's kind of a white crystalline solid. That stuff, of course, is salt, sodium chloride. This is the way Grandma used to make her fresh homemade salt. Okay, none of this Himalayan pink salt nonsense for Grandma. When she wanted salt, she made it herself. So we're going to take the numbers now that we have and figure out the actual yield, the percent yield for our stoichiometry reaction here. And so come along and meet me down on the light board, and we'll wrap this thing up. See you in a moment. Okay, we're back now. Now, let's get some other numbers going. We can have our yield for when we set this reaction up, but now we have some measurements on the result. And scribble down some of the numbers over here. As you saw, the evaporating dish that had the salt in it. Okay, so this is the evaporating dish and the sodium chloride. Okay, weighed 73.89 grams. The evaporating dish itself weighed 71.37 grams. That's just the evaporating dish. And so, of course, subtract the two, pretty easy, and you get 2.52 grams of sodium chloride. Now, that, remember, is the actual measured result. So this is the actual yield. All right. And so we have here our two numbers for the percent yield calculation. We have the 2.52 grams actual. We have the 2.79 grams theoretical times 100. And if we punch that out on our calculators, and there it is, 90.3%. Okay? So I got slightly over 90% of the salt, of the sodium chloride that I could have gotten. Frankly, to be honest with you, if I had gotten anything over 95%, I was going to declare myself super chemist, which we know I am, but here we're at over 90%, I'm going to call myself great chemist, but it is not quite for this one super chemist territory, which hurts slightly, but I'll pull through somehow. And so there you go. A stoichiometry reaction demonstration involving writing the equation, balancing the equation, classic stoichiometry problem, theoretical yield, actual yield, percent yield calculations. Man, such good stuff. And so hope you found that useful. Hope you learned something about it. And we'll see y'all later, folks. Have a good one.